This is Honors Geometry Lesson 7.6, Sine and Cosine Ratios. So yesterday we talked about the ratio of the opposite side over the adjacent side of a right triangle, and we call that ratio a tangent ratio. Now today we're ready to throw in that hypotenuse. So again, the study of trigonometry is the study of the relationship between the lengths of the sides and the angles of a right triangle. And a mathematician figured out the ratio of the sides is always the same depending on that measure of the angle. So we use that ratio. We turn it in from a fraction to a decimal. We put that decimal in our calculator, and we use that ratio to come up with missing sides. So we're ready to go ahead and throw the hypotenuse in now. So we're going to come up with two new ratios. The first one we call sine. It's abbreviated SIN, but pronounced sine. And that's when from the given angle, you use the opposite and put it over the hypotenuse side. And then the last one we need to talk about is from the given angle, in this case it's theta, use the adjacent side and put it over the hypotenuse. So now we've used all three sides, so one of those three choices should always work for you. So how do you know which choice to use? There's a little way to remember this. It's called SOHCAHTOA. And usually when I give my students their paper, their quiz, their test, the first thing they do is write SOHCAHTOA on the top of their paper. What that says is a sine is when you have opposite over hypotenuse. Cosine is when you have adjacent over hypotenuse. And finally, the first one we learned, tangent. Tangent is opposite over adjacent. So you want to see what you're given and what you're looking for, and that'll tell you which of the three choices you should use. All right, so this first one, they just want us to practice using sine and cosine. Okay, this seems a little silly, but just to get comfortable. So from angle B, sine, we know sine, and again, if we write our SOHCAHTOA, sine is opposite over hypotenuse. So from angle B, opposite is 4, and we know our hypotenuse is 5. From angle C, remember that changes. From angle C, our opposite now becomes 3, and our hypotenuse is still 5. Now cosine is adjacent over hypotenuse. So from angle B, the adjacent means beside. We know it's not the 25, that's our hypotenuse. So our adjacent is 7 over the hypotenuse, which is 25. But if we look from angle C, the adjacent now becomes the 24, and the hypotenuse is still the 25. Okay? And this again was just to get you comfortable using sine and cosine. Let's do some real work. Now this one seems a little silly because you're saying, hey, why wouldn't I just use Pythagorean theorem? Absolutely, you could use Pythagorean theorem. Usually you won't be given two side lengths, but they want you to use both sine and cosine just to get comfortable with it. So we'll just try it once. So from the 62, again, if we write our SOHCAHTOA, we're going to use opposite over hypotenuse. So opposite from the 62 is 15. So we're using sine of a 62-degree angle. Again, they know what the ratio of that should be, and they changed it to a decimal for us. So sine of 62 is opposite over our hypotenuse, which is our unknown. Again, I usually put my sine over 1 just so it looks like a proportion for me. And now I'm ready to cross multiply. So 15 times 1 is 15. Sine of 62. You could punch that in your calculator, get a decimal, but why would you want to do that? Then you have to round. We're just going to leave it as sine of 62 times x. To get x by itself, we're going to divide each side by sine of 62. And we find out our missing side. So now it's time to go to our calculator. We're going to punch in 15 divided by, and there's a sine, a cosine, and tangent right in the middle of your calculator, if you can find that. So we're going to say sine of 62. Doesn't matter if I close that parenthesis or not. And it tells me that missing side is about 16.98. So we're going to round that up to 17. Okay. And if we do it the other way, which of course you wouldn't really want to do this all the time, but just to show you, we should be able to use cosine and get the same answer. So we're going to go ahead and use cosine. We know so cosine is the adjacent side over the hypotenuse. So adjacent to the 62 is the 8. So we're saying cosine of a 62-degree angle. We know what that ratio should be. That's in our calculator. Adjacent, which is 8, over x. Again, I put this over 1, cross multiply. Divide each side by cosine of 62. And I'm going to punch that in my calculator. 8 divided by cosine of 62. And I get that it is 17, which we were hoping it would be. Okay. All right, let's try one where we're not given the choices. All right, here we go. It says decide which ratio works best, sine or cosine. So again, maybe I write my SOHCAHTOA to help me out. And I'm going from the 25-degree angle. It looks like I'm given the opposite. I'm looking for the hypotenuse, OH right there. That tells me I'm going to use sine. So I'm going to say sine of 25 equals, opposite has to go on the top. That's the way they designed it, over hypotenuse, which is x, cross multiply, divide. And I'm going to punch this in my calculator. 6 divided by sine of 25. And it tells me the side length is about 14.2, and that seems like a reasonable answer. I knew it was going to be more than 6. Okay, so this one, again, we decide what do we have and what are we looking for. We're looking for the adjacent side, and we're given the hypotenuse, AH, there it is. That tells me I'm going to use cosine. So I say cosine of an 18-degree angle equals, adjacent has to go on the top, that's the way it was designed, over the hypotenuse, which is 15, cross multiply. And I'm going to punch in my calculator, cosine of 18 times 15, close my parenthesis, times 15, otherwise it'll take the cosine of the product of the two, and it tells me that my side length is 14.3, and I knew it was going to be less than 15. 15 was my hypotenuse, so 14.3 approximately. Let's see if we have another one. Okay. All right, let's do one more of these, and then I think we'll call it quits. Get rid of this. It's out of the way. All right, here we go. One thing you can do is figure out the other acute angle. Add these up, subtract from 180, find the other acute angle, and then you can use whichever one you want. I'm just going to go, hey, they did 42 for me. I'm just going to use it. From the 42, this is opposite. This is hypotenuse, OH. That tells me I use sine. So I'm going to say sine of a 42-degree angle equals opposite, which is 7, over the hypotenuse, which is our unknown, cross multiply, divide. And I'm going to punch that in my calculator, 7 divided by sine of 42. And that tells me my missing side is about 10.5, which seems reasonable. I knew it was going to be more than 7. All right, please try the practice exercise. Let me know if you have any questions. Thank you.